Hello everyone, let's work on chapter 1 review. Let f be the function whose graph is given. So I wrote the answer to A through D because it's just finding and eyeballing and estimating values. For example, f of 2 for part A is this point. I thought that this is about 2.7. If you give me a number around that, that's perfect. So if f of x is 3, so it means if the y or the output of y is already 3, if the output is 3, so that's this point or this point, they want to know what are the corresponding x values. So those x values, you need to again eyeball them. So I thought these 2 points are 2.3 and 5.6. Stating the domain of f. So domain is values of x. So you find the reflection of the graph or image of the graph or projection of the graph along x-axis. So imagine that you are making a projection of the graph along x-axis. So where would that cover? So we just go with what we see in the image. So basically that is from -6 all the way to +6. So that would be the domain. To find the range, you find the image or reflection of the graph or projection of the graph, this time along y-axis. So you project the graph along y-axis. So here is the graph and here is the projection along y-axis. So it's going to cover from down below here all the way up here. So that's -4 all the way to +4 down here. Okay. On what interval f is increasing? So increasing means as you are moving from left to right, your graph is going up. So when you move from left to right, your graph is going up from here all the way to up here. So on the increasing, decreasing, you may put it with open interval or close interval. I'm going to use close. So and you are thinking of the interval, so it's from here. That would be x interval. Anytime I say find on what interval f is increasing, you would just go along x-axis. So that would be 1, 2, 3, 4. 1, 2, 3, 4. That's -4 all the way to +4 with the interval notation. Is this function 1-to-1? So it's not 1-to-1 because when you pass a horizontal line, it passes through more than one point. So no. And then the reason is the horizontal line test. Okay. If f is f even, odd, or neither, even or nor odd? Explain. So let's look at here. If f is even, so if you had even functions in the past, so you would say it's even. If let's say like y equal to x squared, when y-axis acts like a mirror. So if you have y equal to x squared, that's an even function. When you replace x by -x, you get the original function back. And in another word, graphically, it's mirror with respect to y-axis. If it's mirrored with respect to the origin, then that's odd. In this case, let's look at the points. If I take that point to the origin and move forward, I have for every single point with respect to the origin, I have a point on the other side. So basically it is symmetric about the origin, so it's an odd function. It's odd because it's symmetric about the origin. Okay. Next question. If f of x is x squared minus 2x plus 3, evaluate the difference quotient. So difference quotient is a very important formula because you will be using that to find derivatives in a few chapters. So let's do this problem. You have f of x already, so it's easy to find f of a. You simply replace every x by a. So f of a is a squared minus 2a plus 3. All I did was I replaced x by a. Now I need to find f of a plus h. In order to find f of a plus h, what I need to do is I need to replace every x by a plus h. So I can put the big model first, parentheses squared minus 2 times parentheses and then plus 3. And then fill in the parentheses with a plus h. So f of a plus h, I replace every x now with a plus h. Okay, all I need to do at this point is to simplify this expression and then replace it in the formula for both of them. Okay, a plus h squared is a plus h times a plus h. So you need to distribute that, and then you distribute the 2, and then you add 3. So when you FOIL here, a times a times h, then h times a, and h times h. So that would be a squared plus ah plus another ah plus h squared. And then now distributing the 2 inside this parentheses, it's negative 2a plus minus 2h. Distributing negative 2 into both. And then plus 3. So now you have a squared plus 2ah, combining ah and ah, plus h squared minus 2a minus 2h plus 3. So I was able to find f of a plus h. Now all I need to do is I substitute them in the formula. So I'm going to make a big line. Let's replace f of a plus h by its equivalent that is right here. So I'm going to replace it here. So that would be a squared plus 2ah plus h squared minus 2a minus 2h plus 3. Now minus f of a. F of a is this minus f of a. So you would have minus a squared minus 2a plus 3. So when you are writing it, remember that you need to distribute this negative inside all 3 of them. So what I'm going to write here is after distribution, negative a squared, positive 2a, and negative 3. all divided by h. Now it's the fun part of canceling. A squared minus a squared. Positive 2a, negative 2a. Positive 3, negative 3. All you're left with is 2ah, h is squared, and negative 2h, which among all three of them, I can factor h. So I'm going to have 2a plus h minus 2 all over h. If you do difference of quotient correctly, the h should cancel, and you should cancel it with factoring. You cannot cancel one individual of them. So 2a plus h minus 2 is the answer. Okay.